In this question, we have a projectile that is being thrown below the horizontal. So what happens, it has a release height from ground of about 0.8 meters. Let's draw the situation. So we have this as the ground level, and it's at 0.8 meters away. So means that it had a release point somewhere here. So what happens is we have an angled velocity that is being angled downwards, 3 meters per second, with an angle of 15 degrees. And if you think about it, the projectile will probably move somewhat like this. Okay, let's first set our origin. So let's take our projectile starting position as the origin, and let's choose a coordinate system. So let me choose y pointing in the up direction as positive and x pointing to the right as positive. The first thing we need to do for this question is to resolve the velocity, since it's an angled component. So we actually need to look at it as a triangle. So we have our hypotenuse here, which has an angle here, and we want to resolve it so that we can get Vix and also Viy. Okay, based on our coordinate system and origin, let's list down our variables. So our initial, where it's before release, our initial position is x initial 0, y initial is 0, and we also have the initial velocities. Vix as 4.3 cos 15, while Viy, okay, based on my coordinate system, as the velocity in the y would be pointing downwards, I put it as negative 4.3 sine 15 degrees. Okay, so we also know that in the y direction, its motion will be influenced by gravity, so I can actually put the acceleration in the y direction, as negative 9.81 meters per second. What about the final conditions? So we are meant to find the x final, so we don't know the x final value, but we do know what the y final value is, and as it's below the origin, it's negative 0.8 meters. So for this question, I would attempt to look for the time of flight, because the time that it takes for the projectile to reach the ground would be the same time that it would have covered the horizontal displacement. So in y, I have y final minus y initial equals to Viyt plus half at squared. So y final is negative 0.8, y initial 0, v initial y is negative 4.3 sine 15 degrees t time plus half negative 9.81 t squared. So if I rearrange this formula, I get a quadratic equation of 4.905 t squared plus 4.3 sine 15 degrees t minus 0.8 equals to 0. And if I solve this quadratic equation, I get time as time equals to negative 0.53 seconds and also 0.31 seconds. Okay, we'll be looking at the positive time, because that's the motion of the ball as it moves in the positive time. So it will actually drop as time moves in the positive direction. So therefore, in x final equals to Vix t plus x initial, and based on the conditions that we have x initial is equals to 0. So therefore I can find my x final, which is equals to 4.3 cos 15, the v initial in the x, times the time, which is 0.31 seconds, and that gives me 1.3 meters. So